Okay, so in this clip, we're gonna go over quiz 4. Okay, so this is one version of quiz 4. So let's look at the first problem. It's a daily output of a factory of this 8-hour shift show that the hourly number units, which is denoted by Y, produced after T hours can be captured by these equations. And you see that the t has to be in this closed interval from t equal to 0 to t is equal to 8. And the first question it asks, after how many hours will the hourly number of units be maximized? So the keyword is this. We want to maximize the hourly numbers of units, okay, which is the y. Okay? So objective is to maximize y over this interval from t equal to 0 to t equal to 8. Right? So this is absolute extrema over closed interval. So the first step is to find the derivative. So you differentiate. You get 70 plus 1 half. The 2 comes down t to the power 1 minus 3t squared. Okay. So you see here the 2 can be cancelled. Okay, so you end up with 70 plus t plus 3t squared. So now we're gonna set this to 0 and find critical values which gonna be in terms of t. So we're gonna rearrange. So we're gonna take t minus 3t squared first plus t plus 70. Okay, and then I'm gonna factor out the negative. So we got 3t squared minus t minus 70. We want this to be 0. Okay. So to solve this, we're gonna factor. So we got t, t, and t. Okay. So you get 14 and minus 5. So you see that if you multiply 14 with minus 5, you get minus 70. And if you take minus 5 multiply with 3t, you get minus 15t, and then 14t plus 14t, and at the end you get minus t. Okay. So CV's first factor give us t equal to minus 14 over 3. The second factor give us 5. Okay, but we can drop this because this is outside this interval from 0 to 8. Okay, so to find the maximum absolute maximum, we come up with this table. There's no need to do psi chart, right? Because we only concentrate on a certain interval. So the first column is the t value, the second column is the y value. First, we have to include the endpoints. So the endpoints are t equals to 0 and t equal to 8. Okay. And then critical value 5, that's only one that is contained in the interval. And now we're gonna plug in into the y. Okay. So remember the expressions of y is 70t plus 1 half t squared minus t to the power of 3. So you plug in 0, t equal to 0, you get y equal to 0. You plug in 8, so this is 70 multiplied with 8 plus 1 half multiplied with 8 squared minus 8 to the power of 3. This is equal to 80. Okay, and then you plug in 5. 5 squared minus 5 to the power of 3. You get 273.5. Now what you do is you compare these three numbers. Which one gives you the maximum? And you see that this is absolute maximum. This is absolute minimum. Okay. So for A, the asking after how many hours, so that's the T. So the answer is t equal to 5. So after 5 hours. B. What is the maximum hourly output? The answer is 237.5 units. Okay. Let's move on to second problem. Okay. So second problem here, it's the integral problem. So we want to integrate with respect to x, and that 1, 2, 3, 4, 5 are 4 terms. Okay. So we got 2x to the power 3 plus 1 over square root of x. I'm going to rewrite this in terms of power. So it's x to the power minus 1 half minus 4x to the power minus 5 plus 5. Okay. So we start with integrating the first term to its out. Integrate x to the power 3, you get x to the power 4 divided by 4. So here we apply the second basic formula. Plus x to the power minus 1 half plus 1, so it's 1 half divided by 1 half minus 4 multiply x to the power minus 5 plus 1, so minus 4 divided by minus 4 plus 5x, and don't forget the constant of integration, which is c. Now we can simplify this, right? You can reduce by cutting 2 and this. Okay. Remember, when you cut this out, you are left with 1, right? It's not 0. So you get 1 half x to the power 4 plus 2 multiplied with x to the power 1 half plus 1, right? Multiplied with x to the power negative 4 plus 5x plus c. And this would be the answer. Okay. Last problem. Now, this one is also integral problem. So we want to evaluate this, which is the integral with respect to x. And here's the function, which is quite complicated. And it said we have to use substitution technique and clearly specify what the u is, right? So we start with u. So let's take u equal to x to the power 3 minus 3x, right? I would say this is a good choice because when you differentiate x to the power 3, you get x to the power 2. The power is reduced by 1, and you see that on the top, you see that there's x squared there. Maybe it will cancel out. Okay, and then you differentiate. 3 comes down, x to the power 2. The second term, you see that it's only 3. Okay, and then we do cross multiply. So dx is equal to du divided by 3x squared minus 3. And you see that you can factor out the 3. So 3, right, bracket x squared minus 1, which appear in the numerator of the functions. Now we're gonna use substitution. So we're gonna use this substitute in the original integral and this. Okay. So first, the x squared minus 1, that's gonna be there. Denominator is gonna be u to the power 3. So don't forget the power 3. Dx is du divided by 3x squared minus 1. And now you see exactly that this cancel with this, and again this cancel. That means what's left is 1, right? It's not going to be 0. Okay. So this is equal to integral of 1 over 3 multiplied with u to the power 3 du. You see that 1 over 3 can be taken out, right? And then we're going to write the function in terms of power. Now you can apply basic formula. So this is u to the power minus 2 divided by minus 2. So again, power added by 1. So negative plus 1, you get negative 2. And after you do the integral, don't forget to add the c. So this is equal to minus 1 over 6 u to the power negative 2 plus c. Or if you want the x back, then last step, substitute back the x. So this, the u is x to the power 3 minus 3x. This whole thing raised to the power negative 2 plus c. And that would be the answer.